I will now demonstrate some real-life products that I have designed using the knowledge and understandings that I have outlined and discussed in the previous two sections. The first, building a SaaS product from scratch. The second, converting and upgrading a legacy product to a SaaS product. And the third, utilizing a vector-based prototype builder to build an interactive application prototype. If a picture tells 1,000 words, then a prototype tells 10,000. Building a SaaS product from scratch. The design objective was to design a web intelligence application for collecting, harvesting, and analyzing open source intelligence, and also being able to connect to an external database, search engines, and social networks, as well as geo-positioning tracking data and collecting hidden content from the dark web. The main use case and persona are a data analyst that collects data by utilizing simple and complex search queries, machine learning, and deep learning to improve the search result accuracy through product usage. Main use case, user workflow. A great way to understand the product is to create use case flows. Here you can visualize the user flow and discuss it with the various stakeholders. Because many applications do not flow in a linear manner, the use case flow is especially important to help people understand how the application works. The analyst enters the system. The analyst now defines the case goals and the objectives. The analyst now creates an investigation or multiple investigations. The analyst now configures the data collection keywords and search query parameters. The analyst now monitors the case level statistics and also keeps track of the individual investigations. The analyst can also view the data using different cross-sections of the data visualizations and representations, and further additional views. And finally, create a case and investigation report. This is the case level dashboard. It shows the case level KPIs, the top social network posts by engagement, the author's location, their gender and age, the data collection history of the case. This is usually the last page to be built of an application, as it is derived from the data views created during development. Additional tabs show post-text sentiment analysis by keyword, the collection source of the posts, and the top languages of the posts. The investigation view is accessed by scrolling down the case view or reducing the case window. This view shows individual investigations included in the case. Each tile shows the current state of a specific investigation. The user clicks on the tile to enter the different data views. The user clicks on the plus button to create new investigations. By pressing on the plus button, the first thing the analyst does is to perform a data collection task. The analyst now selects where they would like to perform these searches. They can search in the surface web and the deep web, which includes membership sites, news sites, and online magazines, forums, and blogs. Or they can collect from the dark web, which is the non-indexed part of the internet, which includes peer-to-peer encrypted content. I used the iceberg as a visual representation, as it is the international symbol that represents the internet. The analyst now configures the scope search collection task. The user enters keywords or multiple keywords in the search criteria input field. The analyst can then add complex queries according to different conventions used by each social network or engine. This view was designed to provide the analyst with a generic way of creating complex search queries regardless of target source. As each social network and search engine employs different query architecture, we had to find a way of making the experience unified. I used the drop menu to keep it clean and ensure the user does not need to exit the system. The user can easily make changes and or updates by removing or adding chip tags shown here in the orange and blue chips. The analyst then clicks on the apply button to deploy the scraper collection task. Once the results are returned to the system, the analyst can then view the result snippets and select the relevant preview items to be added to the investigation. The system machine learns the AI according to the analyst's checking items and adds them to the investigation by clicking on the collect button. The content collected can be displayed using various views in the application. The first prime view is the content view. Each tile contains a headline, a picture, and textual content, as well as comments, likes, shares, and the number of comments collected. The analyst can use the filters to view the collected content according to various available parameters associated with the specific content. The sentiment analysis graph. The analyst can perform sentiment analysis on the collected data. Sentiment analysis refers to the natural language text analysis. I implemented a touch-sensitive bar graph for easy keyword sentiment filtering. The word cloud is also a simple yet powerful visualization that displays the amount of times a keyword appears in a specific collection. The user simply clicks on the word to view all of the relevant content collected. Here we see sentiment highlighting, making it easier for the analyst to decipher the content quickly. The keyword filter. The system automatically divides collected content according to word categories. This is a powerful tool for the analyst to quickly search the database. The connection view. This view shows the relationship between post author and the people that write comments on the post. The analyst can easily see patterns and relationships between people and accurately draw conclusions about the people in the post communication. The extended details. This panel displays the user-selected node items in a list. The user can then click on the list item to view the extended details dialog that shows all of the collected content in context. The action log. Here, the analyst can change the machine learning parameters by scrolling back to a previous configuration search parameter set. The LEDs also indicate the status of the specific collection task, as they can often take a very long time to collect. This is the main investigation management area, where the analyst customizes investigation parameters. This is where the analyst maintains their avatars. An avatar is a virtual social network user profile. This is the social network profile configuration pane. The analyst can add any type of social network user profile from a single pane of glass. This makes it an easy and uniformed process, regardless of the network type. This is the IT dashboard. It is an upsell mechanism. I created the IT dashboard so that customers could monitor their system deployment and purchase more disk space, memory, and bandwidth based on the KPIs that I selected and placed in this view. Converting and upgrading a legacy product to a SaaS product. The design objective was to design an application suite that provides performance monitoring, diagnostics, with a flawless user experience from scratch. The objective was to convert the old legacy interface into a modern SaaS offering. The main goal of this design was to create simple user flows and reduce the amount of pages and clicks. In addition to protecting the customer base of more than 150,000 users, I removed more than 850 screens, which includes thousands of clicks and more than 12 separate external product plugins. The old legacy interface, no user flows, and no end-to-end processes. It's easier to build an application from scratch. It's tougher to take something that has existed for more than a decade and convert it into a sleek user flow and use case-based experience. As you can see here, these screens have absolutely no user flow or clear processes that the user can follow. Just an endless set of tabs, sub-tabs, and sub-sub-tabs, and features and functions in endless lists. Some of the views look like the other views. There's no indication where you are and no process flow. This is the new SaaS product interface that I created by printing out all of the old screens, placing them on the floor, and eliminating the overlapping features and functions. This is the application service dashboard. It is the central location where the user monitors, creates, and maintains their service application portfolio. I singled out the three main KPIs: service availability, service performance, and hardware health systems, as you can see as the three tab controls on each of the tiles. By clicking on one of these tiles, exposes the extended overview of each of the applications over time. By combining multiple separate views and graphs into a single pane of glass, I improved the user understanding and experience and exposed the interdependability of the following system attributes: performance, availability, failures, alerts, and traffic volume. All of the system changes affect one another, and the user could not quickly find out or focus in the system and find out what the actual problem was, because none of this information appeared in the same place. After studying the user log files, I was able to understand the required KPIs that the user was using in order to achieve mission-critical success. Here we see the SLA view. where the user can easily monitor their service level agreements for each of their applications and customers. By clicking on an application tile, the user easily can view the historical data and system downtime for each of the service level agreements. In this view, I use the topology graph to show the relationship between the transactions within the context of a single app. In this example, an online banking application. Here, the user instantly gains understandings about any or all locations on this simple overtime graph and can also compare locations with the click of a checkbox. This is the layer isolation view. The user uses it to monitor the website response time and can use the different time frame selection buttons in the top right-hand corner of the screen to view the different segments over different time periods. The component breakdown details provides the user with a visual understanding of how a specific website loads into a browser client. The world map is what every product manager wants so that they can show this view at an international conference, with lots of LEDs flashing according to the amount of traffic of a particular monitor site. I will now demonstrate how to utilize the vector prototype building application to create interactive product prototypes. For this demonstration, I will be using Adobe XD to build my prototype. I will first show you how to start designing an application. Then I will show you how to build an interactive prototype. And finally, we'll show you how to share the design spec with a developer, including everything they need to build a pixel-accurate application interface that matches exactly the design specifications created here. This is the main canvas of the application. This is where the user affects change and constructs different pages in order to build the application. As you can see on the right-hand side, all the CSS configurations are made here, affecting changes on the panel itself. The user then makes multiple screens, templates, and uses these templates, demonstrated here, to construct flow sequences of the application, as you can see here. Once I've constructed my flow sequence, including all of the elements and items I wish to show or demonstrate for a specific feature or user story, I then can go into the prototype mode, where I can now start connecting all of the different elements and their click sequences. For example, if you look carefully, you can see that each one of these lines is connected to a button. Each one of these links can be attached or detached to a different window to affect and create animative change and fully functional prototype building. Once I've created the prototype, I can then expose it to different stakeholders. They can then go through the click sequence as a user would, fill in the details, activate their account, click on the relevant tooltips, view the relevant information, continue through the click sequence, turning on and off tooltips, clicking on buttons, exposing different views, opening drop menus and scrolling the different options available, continuing down the user flow, visualizing all of the different animations, all the different effects utilized to construct the application itself in order to receive a holistic, end-to-end, pixel-accurate user flow, which can be easily translated into the required information for the developer to build the application itself. This is an incredibly powerful tool, and it's a revolution. And I can see in the future that this prototype builder will eventually replace a front-end developer's IDE application construction tool. You'll be able to develop the front end of the UI using a visual tool just like this. I hope you've enjoyed this small window and looking into the world of creating interactive UI prototypes, and you'll be able to utilize this information for the betterment of your own products and designs. To flatten the learning curve and to shorten the time to market of a product, it saves time and money and stops many useless and pointless arguments from actually transpiring because the information is clearly transferred from the designer to the developer to the customer in one quick, easy step.